Hi guys, it's been a long time because I was, getting ready to graduate, and soon I'm gonna start work. Uh, yeah, I will try to make it more and more. You know what I mean? Uh, I try to make a time, to share my knowledge, and I will also learn it from you guys. Or while I'm preparing this, I also could learn it. Today we will learn about, by the way, synchronous generator, power and torque. And we will try to draw the pager and equivalent circuit and torque angle. We will learn it. Yeah, it's kind of a little bit hard part, but I will not that explain deeply. You know what I mean? At least you need to know about this. If you guys wanna be experts. So first of all, as you guys know, synchronous generator need a DC source, you know what I mean, to make excitation, right? So this is excitation winding. I make it more easily, to make you guys understand easily. If you say, yeah. So first of all, here we need to DC source, and then this is a rotor part R, and secondary part is here, stator part, right? And here's load. I will say load, and this is stator part. So I wanna say is guys, first of all, we need to make it current from DC source, right? So I will say this is IF, exciting current, right? So it makes it the pi, right, from the coil. I will say pi F, and then equal to the stator part, right? And actually it make it the where is it? Color yellow. Yeah, here's it make it E. You know what I mean? Pi F make and the stator is make it EF, right? And then once if there's no load, there's no current, right? So which means it's done. But what I mean is if we edit I, you know what I mean? What I mean is load. So it's make it current right here. And because of the, as you guys know, Lenz's law, if there's, what I meant is I and flux is, I said, always happen at the same time, right? It's a meter and me, right? So because of the load, the I makes a pi. Here's again I. So I will say I pi A, this one. Because of the load current, it makes this in the stator part here. So actually, look at that. So I will say pi net. Sorry, pi net is equal pi f. We make it from here, right? Plus pi A. So pi net means the sum of this. But we will say this part because of the load, right? It depends on the load. You know what I mean? So because of current, it make it flux, something flux is made in stator. So we will say this is armature reaction. I will not, I make it deeply about the how about the mechanism, why it I will say today result, okay? Uh, Depending on the load, if it's inductive load, the armatures, you know what I mean, reaction is make it decrease. But if it's inductive load, no, capacitive load, it make it the armature reactions happened to make it the pi net more bigger. You know what I mean? If it's a capacitor load, the pi net's gonna be, the magnitude is gonna be increased. But inductive load, as I said, decrease. That is the result. I'll make it the lecture. Don't worry about it. Just why it happened, since we add the load, and then because of the, since I current is coming, right? That's why the reaction is happened. That's it. You guys today need to know. Remember, okay? Yeah. And let's see. So don't worry about it. Look at that. This is happened in the only synchronous generator, especially this part, right? We just now learned innet, right? So this first part, armature reaction part, right? And this is second part, this green line, as you guys, we already generally know about this diagram, right? So this is Cooper's register and the leakage, reactance, right? And one thing is this JXA, I will say is armature reactance, you know what I mean? The magnitude is, I say 99%. It's almost, the value is here. Like, for example, this is a 90 ohm, and this is a 1 ohm here, these two. So mostly this is because of, we say just sometimes, I will later tell about it, more about it. But what I mean is we could also neglect this part because this armature reaction part is mostly, it has the values, you know what I mean, the circuit. So today we will learn about drawing, you know what I mean, pager drawing. It's really important. So as you guys can see, we first of all need to make a equation, you know what I mean, voltage equation. So pi f, I will separate, you know what I mean, here, right? IF equal E net plus IA JXA, right? And E net is equal V plus, because I is here, right? I is coming here, and IA, and lines register and the leakage reactance, right? So we will try to drawing this. So I will explain. So first of all, we learn about, we made it voltage equation, right? So remember part is this part I said, because of depending on the load, the armature reaction happened, right? It depending on the load. If it's inductive load, the net is gonna be smaller. You know what I mean? The magnitude is decreased. In this case, is this. I will show you. So look at that. First of all, we need to find out the reference point. Reference point is here, V. So V is the reference point is a yes, standard point. So V equal here. And I said our general situation is current is lagging. So that's why I made the lagging here. This is the theta, I will say, between them. And there's a R and JX, right? And R is more, when you draw it, R is gotta be more smaller. But R is, first of all, the register is the same in phase with the current, right? So that's why I add here RA. And then J is, I said 90 degrees, look at the here. Here's a 0 degree here. And here is a J, right? 90 degrees. So I will say it's a 90 degrees more. So look at that. From here, 90 degrees, right? More faster, precede. So that's why leakage is here. I draw here. And then if I, make it the line, the sum is E net. And E net plus X, right? XA. JXA, right? So which means J is the same, right? But as I said, the armature reaction part is mostly charged, right? Armature reaction part is mostly charged. So that's why largest longer line here, here. And then EF is, that's why EF we make it is. So by the way, EF is exciting, current because of the exciting current it made it, right? Because, yeah. So from the outside of a DC source, right? But actually, as you guys remember, current IF make it I pi, right? Sorry, pi f, right? It make it EF, right? So which means this this is 9 degrees differences because it causes this, right? It causes this. This two is a different dimension, so we cannot say these two are different pace. This is different dimension. But by the way, IE and pi is the same, right? So that's why it's it make it this cos, right? So that's why 90 degrees more precede, right? 90 degrees. This is IF. You know what I mean? So we will say also IF also here. So, and then pi net is also same because E net is made by the pi, right? So that's why also 90 degrees here. But what I mean is this is now, look at here. Pi net is pi f plus pi armature, right? But as you know, armature is here, lagging current, right? Because of lagging current here, right? Lagging is the same. We just add it here, right? So that's why now the result is pi net is gonna be more smaller, right? When we add these two, right? The magnitude, the long, the distance, you know what I mean, between these two lines is more smaller than IF. That's why we say in the inductive load, we will say it causes the decrease. In capacitive load, it changes. So the result is here. I will withdraw. So in the capacitor, look at that. Yeah, we ignore this part, okay? Just capacitor leading current is here, right? So look at that. Leading is if we add it here, here, and the pi net is gotta be here. The result is this. You know what I mean? I will later, explain you guys why it happened, or how it caused this situation. You know what I mean? Just gotta be more familiar about this. And then, yeah, this is I wanted to one part. I wanted to explain one part, armature reaction, and drawing the pager and then this circuit, equivalent to circuit. It's a basic concept. If you wanna guys someday wanna be a expert in as an engineer, right? Have to know, have to memorize. You know what I mean? And then second part, I wanna say is torque angle. I would say. Previous lecture we made torque. I will show you more first. Yeah. So I will say torque is here, this angle we say. But you guys can see here, VA and EA. Look at it, guys. So actually, it gotta be RA plus JX. And then here's it gotta be E net, E net. And plus armature reactor. You know what I mean? JXA. And then it gotta be EF. It gotta be like that, actually. But as I said, you guys can see here, the previous here. The lines resist and leakage, reactance is really small. Mostly it has, as I said, 99% is amateur reactions value, right? So sometimes we could neglect it. So this is the the diagram. You know what I mean? Equivalent to circuit. We neglect, just ignore the R and JX. You know what I mean? So as you guys can see, we already try to find out how to make this equation. But in case we will try one more time. You know what? Actually, you don't need to memorize this about. Just you guys can need to just memorize this, or no. The result you guys can just, it's fine. You know what I mean? So let me see. Yeah, whiteboard. So as I said, we first of all to make equation, voltage equation, we need to make it drawing the equivalent circuit. So E and here I and JX, and here V and here. So in this time, I will say this is total reactance. What I mean is we neglect R plus JX. You know what I mean? We ignore. We only consider this part is armature reaction part, right? So first of all, we draw it, right? And then we need to make it voltage equation, right? And V plus I, J I X S, right? More easily, I will say, we need the reference point here, right? So I will say this angle is delta. So E delta equal V 0 plus J I X S. Yeah, we make it this, right? So as you guys can remember, apparent power, you guys remember, right? But we need to conjugation to I part, right? So actually in this part is we could change it to E, right? So we will make it first of all, try to find out I, okay? So what I did was this, guys. First one, E delta JX S, and this is the 0, right? So I made it this, right? So if I do change it to I, find out I is J X S B delta S V 0. This is I, right? So what I need to is make it we find out this, okay? So E delta multiply. So we need to conjugation, right? So E minus delta minus 3, because there's a 0, so we're gonna, right? And then minus J X S, right? And then it's kind of messy. Sorry, I tried to make it. So we first of all right. So if we multiply here, E to 2 minus E delta E delta minus 3 0. Oh, sorry, guys. Oh yeah, sorry. Yeah, EV delta, right? And then minus J X S. Sorry, guys, kind of confusing. So we will multiply, J is here, J is here because we remove one of this, right? So E to 2 minus J E V delta, and then X S, right? And we make a polar, which means we need to find out the real part and then imaginary part. We need to divide, right? So J E to 2 minus J E V cosine delta plus E V sine J E V sine theta. No, delta and X, right? So if we JJ, look at that. So JJ means it's here, this part is gonna be real part P, right? P equal XS JJ E V sine theta. P is this, right? And Q is XS and J E minus and EV cosine theta. Yeah, this is we try to find out, how to find out the equation. You know what I mean? But you don't need to know about this. I'm also, sometimes I do it, rarely. So I'm also confusing. So I memorize just the result. You know what I mean? So let's see, guys. Yeah, today is kind of difficult, right? Yeah, but yeah, it's a it's a really helpful for you guys. Also for me to familiar with this, right? Or yeah, we find out this via cosine center, right? So first of all, as you guys can see, torque angle, right? Torque angle is these triangles from here, delta, right? This is theta, and delta is little bit weird because not weird. You need to memorize something. So look at the first one. This point, we say the result is it cannot be over 90 degrees. You know what I mean? So we say 90 point, this point is here, we say critical stability point. And if load angle is exceed 90, it's the alternator will become unstable and its speed can go out of control, you know what I mean? So which means it gotta be negative effect if over 90 degree. The result is this, you know what I mean? So to make a safety, we generally operate between 20 and between 30 degrees. The result is, you know what I mean? So we cannot over this, you know what I mean? 90 degrees, these angles. So what I mean is this is number one, the gray, and blue is number two. Look at that. We first of all, both are lagging current, right? So first of all, number one situation is we only change it to add. This is reactive part is the same. Reactive is so we say same, but we added only active power, active current, so we added more. So since we added active power, what happened here? The torque angles is gotta be more bigger, the result is, right? So what I meant is since we added more and more the active current, you know what I mean? So which means that the angles gotta be or 90 degrees, you know what I mean? These deltas. But we cannot over deltas. So we will say 90 degrees. This is a critical stability, I will say. The result is this. And then what I wanted to show you guys is here. Look at that. I'll make a triangle here, right? So look at that. This is 90, right? And then this is the same, this angle here, right? And then this angle, and then this angle, theta, right? So which means here's what was it? JXS, right? Because we neglected the R and leakage reactance, right? This is armature reactance part, right? So this is a cosine, right? Cosine part, which means P. That's why this part is, you know what I mean? Related the delta, you know what I mean? If we add more and this angle, which means the powers, you know what I mean? The out of powers, you make it power, right? It's gonna be more bigger. But what I mean is we should remember this angle. We cannot over this. Don't worry about it. Just that this is you know, little bit I'll try to explain you guys what we gonna learn later. You know what I mean? Deeply. Just gotta be more familiar. Oh, we cannot over 90 degrees about the torque angle. You know what I mean? Yeah, that's it. This part. And then the last part is here. This, you know, I said this is making from, my pencil. Yeah, this is exciting current part, right? And this is armature current. And then when we add these two, to make it pi net, right? Between this angle is we say torque angle, what we get it, right? And then between them, this pi and the net, they wanna be together. You know what I mean? But we say this is self-aligning torque. You know what I mean? This is a self-aligning torque here. This phenomena. And look at that. This is prime mover, and the torque is gonna be here, right? Like for example, it doesn't matter this way or this way, but the result is this torque angle is totally reverse side. You know what I mean? If it's go to the rotary is like this way, clockwise. What I mean is, yeah, my prime movers turbine is clockwise, right? But the torque is happened the counterclockwise. You know what I mean? That's it. Yeah, that's our today's lecture. Thank you, guys.